Okay, we're now recording. So give me a moment to set up the share screen as usual. Okay, so we have two sections left, 2.7 and 2.8. It's on the derivative. Okay, that's for all of this week. Okay. Normally, I like to reserve the Thursday before a test for questions and answers. I'm not positive I'm going to be able to do that this time, but we'll see how much I get through the next 3 days. Okay, so next exam is this coming Friday. Now that you've seen one test, you know how the tests work in general. Okay, so you have the entire class period to do that. A little bit after 9, maybe 9:01, 9:02, I'll send a test via Canvas announcements. So look for the test in Canvas announcements and just work it out. And keep yourself muted, but have your actual camera. That's the only time I need the actual camera on for you during the test. And so you have until our usual stopping time of 10 o'clock to finish a test. Give you 5 minutes to take pictures on your cell phone. So 10:05 to submit the test and 10:30 to submit the homework. There's a 70% homework requirement. If I don't get at least 70% of the homework, I don't grade your test. And again, the 70% requirement is not really that hard considering I do a great percentage anyway. Okay, so 2.7 and 2.8, it's on the derivative. I'm actually going to treat these as one section. So you'll see me bounce back and forth between both sections because I'm really treating it as one great big section all on the derivative. Okay, and in case you're wondering why I do that, well, the author has sort of done that too. The author takes a derivative from the definition standpoint and then graphical, and then he switches back and forth between that. So I want to get lots of graphs together and get lots of definitions together. I'm going to focus mostly on a definition of derivative today. I'm not sure I'll get to any graphs today. So you'll see me bounce back and forth between the two as one great big section, as it were. Okay. All right, so again, I'm not promising I can give you a Thursday for questions and answers. We may just have to continue lecture until the test on Friday. Okay, coverage is just chapter 2, so I'll ask questions from here. Now I tend to give one question, well, 10 questions total, so we have 8 sections, so there's going to be one question from each section and probably another couple from somewhere. It's the most likely scenario. Okay. All right, so let's go straight to the derivative and problems involving it. Again, the only definition of the derivative that I want you to know about is in 2.8, page 152. And let me aim my document camera better. We could. Okay, so box number 2, f prime of x, f apostrophe x, we say f prime of x, limit h approaches 0 of f of x plus h minus f of x all over h. Okay. So that is that. And let me go over the homework pages for those of you that aren't planning to get the book. So 2.7, we had to go from 5 up to 43. So let me try to give you all that now. Page 148. Okay, so hope that's 5, 7, 9, 11, 13. And let's see, 15, 17. Oh, we didn't have to do 18. Somewhere there up to about 23-ish. 25, 27, 29. And the ones at the bottom, 31, 33, 35, 37. Okay. And let's see. We had to go to 43 also. So, and that looks like 43. Okay. And while I'm at it, might as well get you 2.8. Again, I'm treating it all as one great big section, so to speak. So we had to go up to 44, I guess. So, okay, 2.8. Oh, what's the page? 160. Okay, there's 1, 3, and let's see, 5, 7, 9, and 11. 13. And how high do we have to go? 44, I guess. Okay. I don't think we had any of those. So there's those. We have to find derivatives of those. We might get to some of those today. Again, anytime you see that graphing calculator icon, this thing, you don't have to do it. That requires a graphing calculator. Since I'm not requiring you to have a graphing calculator, skip any part that says using graphing calculator to do blah, blah, blah. And then let's see, just 41 to 44, I think. Yeah. Okay, so I think that's it. Okay, so for the definition of the derivative, just a little bit of a background of what's happening. Okay, so we've talked before about the equation of the tangent line to the curve. Okay, so here's a curve, it's arbitrary, 2.7 and 2.8. Here's a point x comma f of x. Here's x plus h comma f of x plus h. Okay, so here's the x-axis. So where's the y-axis? I'm not putting it intentionally. It just kind of clutters up the picture. It's somewhere, but we don't care. Okay, so the green is some curve. So if I connect any 2 points of a graph, that's called a secant line, S-E-C-A-N-T, just like the trigonometric secant, but it doesn't mean the same thing. Okay, so I just connect 2 points. Okay, so what's the slope of the secant line? Well, y2 minus y1 divided by x2 minus x1. So that's f of x plus h minus f of x divided by x plus h minus x. Okay, so in red, you see y2 minus y1 divided by x2 minus x1. Okay, now you can't do anything more with that, but you can do something here. That's just h. X plus h minus x is just h. F of x plus h minus f of x all over h. So that's the m, the slope for the secant line. Now, if I want the slope of the tangent line, we saw way back in section 1, to let this point get closer and closer and closer to my fixed point, we now know how to say that more accurately, the limit as h approaches 0, right? So when this point gets really close to this point, we mean h approaches 0. So the m for the tangent line is this expression as limit h approaches 0. So limit h approaches 0 of f of x plus h minus f of x all over h. And that is our definition of the derivative of a function. Okay, now if you didn't understand this derivation here, that's okay. Just know this, put this on your cheat sheet. Definition of the derivative. Okay, again, in a book, you'll see other definitions of the derivative. They're all correct. There's 3 or 4 other ones, and I figured out I'll just give you the main one, and that's all you need to worry about. Okay, so f prime of x is the way we say it, f apostrophe x. The derivative of f of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. This is basically y2 minus y1 divided by x2 minus x1. Okay, and my focus on today is to do a lot of problems involving this definition. Okay, and as you might guess, the hardest part for students is this part. There's always an h on the bottom, that's no big deal. Minus f of x, that's just the original function, that's usually not a big deal. This is the hardest part. Okay, and for all these problems, there are limits you never can plug in directly, because if you plug in directly, you're dividing by 0. So there has to be some algebra trick that we've seen before with limits to cancel this out. So then we can finally plug in. All right, so I'm going to get started with a whole bunch of them now. Okay, so 2.7, number 7. Y equals the square root of x at the point 1, 1. Okay, the question is find the equation of the tangent to the curve at the given point. Okay, so I can show you quickly. 2.7, number 7. Okay, find the equation of the tangent to the curve at the given point. Y equals square root of x at the point 1, 1. Okay, now you don't actually have to graph it, but I got a little mini graph right here. Here is the square root function, y equals radical x. Okay, here's the point 1, 1. There's a tangent line. What is the equation of that tangent line? Okay, we're going to be able to come up with that now. All right, so I plug into the definition. And again, this is the part for sure, those of you who have calculus backgrounds, you're going to want to use shortcuts. No shortcuts here. If I see any shortcuts, you automatically get a 0. Okay, pretend you don't have any calculus background. You got to do this. Okay. All right, so by definition, it's the limit as h approaches 0 of f of x plus h. It's the square root function. So square root of x plus h minus square root of x all over h, okay? And we've seen this game before. In this case, you want to rationalize the numerator. This looks like a minus b, so I multiply by a plus b, it's conjugate. So radical x plus h plus x, top and bottom, okay? So this is the f of x plus h, this is f of x divided by h. Don't plug in. If you plug in, you're dividing by 0. So multiply top and bottom by the conjugate. So now the numerator looks like a minus b, a plus b, right? So now what is a squared? That times that is just x plus h. Minus b squared, what's radical x squared? Just x. All over h times radical x plus h plus radical x. Notice I don't multiply out the bottom. It's usually not worth it to multiply at the bottom. Okay, and notice very conveniently the x's cancel out. X minus x cancels, so you have an h on top. Guess what happens to that h on top? Cancels that h on the bottom. That's usually the trick. So that cancels out, so you're left with a 1 on top. So limit h approaches 0, 1 over radical x plus h plus radical x. Now I can plug in 0 for h, no trouble. Okay, again, please notice I look for writing too. You have to write mathematics properly. So you keep writing limit h approaches 0, limit h, lim, h approaches 0 until you're ready to plug in, right? Up until that point, I could never plug in, right? Because you're dividing by 0. You can't plug in here, can't plug in here, can't plug in here, and say, oh, I can finally plug in because I got rid of that h. Now I plug in 0. So once you plug in, you don't have to write the lim anymore. So don't write lim, 1 over radical x plus radical x, which is 1 over 2 radical x. Okay, your final answer should not have a lim. So this is the derivative function. Please notice that you start off with a function. The thing that you come back with is also a function. It's a new function. It's not the same as the original. It was derived from the original, hence we say the word derivative. Okay, it gives you the slope anywhere. So we have a slope formula. You want the slope anywhere on this curve? Plug in here. Okay. Now in this particular case, they want the slope at the point 1, 1. So I plug in 1. 1 over 2 radical 1, 1/2. All right, then I throw it into the point slope form and you can stop after that. Point slope form is y minus y1 equals m times x minus x1. Okay, so y minus 1 equals 1/2 x minus 1. And now you can stop. Okay, I will let you stop once you get to this stage right here, but I need to see this. Okay, again, some of you have been avoiding the point slope form. You've been going straight to y equals mx plus b. I need to see the point slope form. So if I don't see this form right here, I may decide to take off points for that. Okay, this is the preferred form for now. Okay, this is the equation of the tangent line. It's very powerful what this derivative can do now. It gives you the equation of the tangent line to the curve. So right there, the question mark, what is that line, that tangent line? That's what it is. Okay. Okay, 33, I'm jumping over to 33. It asks for the derivative of f of t is 2t plus 1 over t plus 3. You get some pretty messy algebra here. That's pretty much it. And also instead of x, it's t, but no difference. So instead of x plus h, I'm going to write t plus h. That's all. All right, so f prime of t is limit h approaches 0. So great big fraction divided by h. Okay, this side is f of t. This is f of t plus h. F of t is just the original. So just copy 2t plus 1 divided by t plus 3. The hard part for students is usually this part, f of, in the formula it's x plus h, but here we're using the letter t, so it's f of t plus h. So pretend you erase that t, put parentheses t plus h. There it is. Pretend you erase that t, put parentheses t plus h. So now it looks like this. Okay, so replace t with parentheses t plus h, replace t with parentheses t plus h. Okay, now try to clean it up. It's very messy. First thing I'm going to do is this. Anytime seeing a complex fraction, a fraction inside a fraction, okay, it's much easier to do this. Instead of dividing by h, I will multiply by 1 over h, right? If you divide by 7, it's the same as multiplying by 1/7, right? You multiply by the reciprocal. It just makes it look nicer. This looks kind of weird, have a fraction on top of a fraction. Okay, so instead of dividing by h, I'll multiply by 1 over h. Okay, then I got great big brackets here. Okay, in black, 2t plus 2h plus 1. The bottom is t plus h plus 3. Temporarily ignore the red. Minus 2t plus 1 over t plus 3. Okay, so far from here to here, all I did was instead of dividing by h, I multiplied by 1 over h, multiply this out, and leave a space. So now what's the red stuff? That's getting my common denominator, right? So what's the common denominator here and here? Well, the game works, whatever is on this side, you need, over there, and whatever is on that side, you put over there, right? So t plus h plus 3, t plus 3. To get a common denominator, this side needs t plus 3 over t plus 3. This side needs t plus h plus 3 over t plus h plus 3. Okay, so the denominator is now t plus h plus 3 times t plus 3. And what's all this junk here? It's all of this multiplied out. Okay, so I have to multiply all this out. There's a trinomial times a binomial. 3 times 2 is 6. There's a binomial times a trinomial. 2 times 3 is 6. Okay, so it's going to be 12 total terms. I'll show it to you in a second, but okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Okay, and something else I'll show you. I know I didn't give you enough time to look at it, but okay, these are all positive. Do you agree? Now, if I ignore the negative sign here, all 6 of these are going to be positive. Agreed? If I just ignore the minus, they're all positive. Now I put the minus sign, that means they're all negative. Okay, so the first 6 are all positive. Plus, 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 plus. And the last 6 are all negative. Minus, 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 minus. Okay. All right. So let me see if I can kind of go in pieces here. 2t. 2t squared plus 6h. 2t squared plus, sorry, 6t. 6t. Yeah, 6t. Now, 2h times t plus 3. 2ht plus 6h. 2ht plus 6h. And then 1 times t plus 3, t plus 3. Okay, so that's that. Now all the minuses. Minus 2t squared minus 2th minus 6t. Minus 2t squared minus 2th minus 6t. And then 1 times that. 1 times that, these are just going to be negative. So minus t minus h minus 3. Minus t minus h minus 3. Okay, so here's the 1 over h. Here are the 12 terms. Okay, so I'll leave it there just for a moment, but you can always look at the video later. So it's 2t squared plus 6t plus 2ht plus 6h plus t plus 3. And then the 6 minuses, minus 2t squared, minus 2th, minus 6t, minus t, minus h, minus 3. Okay, and now, as you can see, there's a lot of stuff that cancels out. 2t squared cancels out. 6t cancels out. 2ht and 2th cancel out. Minus t cancels out. 3 cancels out. Okay, the only thing that doesn't cancel out are the ones that I have circled, 6h and a negative h. That's 5h. That h cancels that h. So there we go. So finally I have it. So limit h approaches 0 of 5 over t plus 3, t plus h plus 3. Okay, almost all these problems, the key is to get rid of that h, right? Because you can't plug in 0. Now that I got rid of the h, I can plug in 0. Okay, if I plug in 0, I'm not dividing by 0. So that's going to be t plus 3 times another t plus 3, or 5 over t plus 3 squared. Okay, then one final step is they actually ask for f prime of a. So just change that to a. Okay. Right, so you can see there's some heavy duty algebra for a lot of these derivative problems you see. Okay, and jump back to number 9. Okay. Okay, number 9, find the slope of the tangent to the curve y equals 3 plus 4x squared minus 2x cubed at the point where x equals a. Okay, B, find equations of tangent lines at the point 1, 5, and 2, 3. Skip C because it has a graphing calculator icon. Okay. All right, find the derivative of this. Again, those of you who know the shortcut, you really want to do the shortcut. I really want to do the shortcut too. Those of you who have no idea what I'm talking about, once we get to chapter 3, you learn the shortcuts. The shortcuts are very great. Okay, can't do it now. So anybody who has calculus background, you show me the shortcut, you get no points for this problem. Okay. All right, so instead, throw it into the definition. So f prime of x or y prime. So y prime means derivative. F prime of x, y prime also means derivative. Limit h approaches 0. So it's f of x plus h minus f of x all over h. Okay. The easy part is always divided by h. In my opinion, the f of x is not so bad either because all you do is copy the original and put it in parentheses. So 3 plus 4x squared minus 2x cubed is the same as the original in parentheses. Okay, the hardest part is always the f of x plus h. So f of x plus h. Right here and right here, pretend you erase the x, put parentheses, x plus h. So here we go. 3 plus 4 parentheses x plus h squared minus 2 parentheses x plus h cubed. This is just some heavy duty algebra. Now, let's see. Limit h approaches 0. 3 plus 4 x plus h squared is x squared plus 2xh plus h squared minus 2. Okay, we have done this before, x plus h cubed. I don't want to take up too much extra time on that. Okay, you can just go x plus h times x plus h times x plus h. Or another thing you could do is this is x plus h squared, right? So you can take this and just multiply by another x plus h. Some of you know a shortcut using Pascal's triangle. You can do that. I'll emphasize that more maybe when we get to the 4th power. But in any event, I'm just going to go straight to from here to here. Okay, I trust you can do that. X plus h cubed is all this. X cubed plus 3x squared h plus 3xh squared plus h cubed. But we've seen it before. Okay, worst comes to worst, just go x plus h times x plus h times x plus h. And then minus parentheses means just change every sign. Minus 3, minus 4x squared plus 2x cubed. Okay, multiply all that junk out. So 3 plus 4x squared plus 8xh plus 4h squared, distribute the negative 2. So minus 2x cubed minus 6x squared h minus 6xh squared minus 2h cubed. And just leave these guys alone. Now cancel stuff out. 3's cancel. 4x squared cancels. Negative 2x cubed cancels. I still have a lot of stuff. 1, 2, 3, 4, 5 terms. What do you notice about the 1, 2, 3, 4, 5 terms? They all have a common factor of h. Okay. And by the way, you might say they have a factor of 2. That may or may not be true. It's irrelevant. I don't really care about the 2 right now because the 2 not going to cancel. The main thing is to cancel the h on the bottom. So I'm only going to factor out the h. H parentheses 8x plus 4h minus 6x squared, taking out the h, minus 6xh minus 2h squared all over h. And there it is. Now the h is cancel. Notice you keep writing limit h approaches 0, limit h approaches 0, and so on. So after the h is canceled out, I just have the numerator 8x plus 4h minus 6x squared minus 6xh minus 2h squared. Now I plug in h approaches 0. You basically plug in 0 for h. Don't plug it in for x, by the way. It's always h. So that goes in nothing. That becomes nothing. That becomes nothing. So y prime is 8x minus 6x squared. That's my answer. Again, very, very technically, in the limit, I am plugging in 0, but this really means you're plugging in a number close to 0, 0.00001. But if I plug in 0.001, that's like nothing, and that's like nothing, and that's right. So there's my derivative. Okay, a quick word for those of you who know shortcuts. I'll let you use the shortcut as a double check. Those of you who have no idea what I'm talking about, you can't use this as a double check. But if you double check with a shortcut, then you know, oh yeah, it is 8x minus 6x squared. But I do need to see all of this work. Okay, now they say, what's the derivative at a? Just put an a there, 8a minus 6a squared. Okay, then they give you a particular point, 1, 5, and 2, 3. I'll just do the 1, 5. You can do the 2, 3 later. So question 9b, 1, 5, and 2, 3. I'll just do the 1, 5. You do the 2, 3. So I plug in 1 for x and 5 for y, but there's no y to plug in. So just put a 1 right there and a 1 right there. So 8 times 1 minus 6 times 1 squared, 2. Slope. Point, slope. Y minus y1, y minus 5 equals m times x minus x1, x minus 1. Stop right here. Okay. Meaning, you know, and I know we can keep going to y equals mx plus b. We don't feel like it. We will be forced to do it a little bit later in the course. But for now, we'll stop as if to say, we know how to do it. That's algebra 1. We're focusing on the calculus now. So just stop right here on the homework or quiz or test. That's good enough. Okay, 13 asks for velocity. Now, velocity means derivative. We talked about that a little bit in section 1. 13, if a ball is thrown into the air 40 feet per second, its height is given by y equals 40t minus 16t squared. Find the velocity when t equals 2. Okay, so velocity is rate of change of distance divided by time. In this case, it's feet per second. So velocity meaning instantaneous velocity. So it does mean derivative. Okay, so whenever you see velocity or instantaneous velocity, it is a derivative. So find a derivative at t equals 2. Okay. And yes, once again, you people who know the shortcut, you want to do the shortcut. Sorry, you can't do it. Okay, I'll let you use the shortcut as a double check, I suppose, but you can't have that big of an advantage. All right, limit h approaches 0. Again, instead of x, we're using t. So instead of x plus h, it's t plus h minus f of t all over h. So there's the h on the bottom. Okay, this side is just the original function in parentheses, 40t minus 16t squared. So again, I think this is easy. H, you got to get that right. And this is not that bad. You just copy the original function in parentheses. The only hard one is this one. So minus parentheses original function, 40t minus 16t squared over h, that's easy. And now right here, the way a function works, anytime you see t, change it to t plus h. Change that t to t plus h. So it looks like this. 40 times t plus h minus 16 times t plus h squared minus parentheses 40t minus 16t squared all over h. Okay, and do the algebra. Limit h approaches 0. 40t plus 40h minus 16 Okay, t plus h squared we know is t squared plus 2th plus h squared. Okay, and distribute the minus sign, minus 40t plus 16t squared all over h. Okay, let me move my document camera a little bit. Okay, I got to go back up the paper, but distribute this, right? That's going to be minus 16t squared minus 32th minus 16h squared. Everything else is going to be the same. So there we are. Okay. All right, so 40t cancels out. 16t squared cancels out. So I have that one, and that one. 1, 2, 3 terms. What do they all have in common? H. That's going to be a recurring theme. You can pretty much bank on it. There's going to be an H because you know you got to cancel that H there. Okay, so gone, 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 gone. H paren 40 minus 32t minus 16h all over h. Cancel out the h's. Limit h approaches 0, 40 minus 32t minus 16h. Now I plug in h equals 0. Again, technically, that's not what it says, but if you plug in 0.0001 or negative 0.001, that approaches 0. So that's gone, 40 minus 32t. So that's my velocity function at any time for the original. And yes, those of you who know the shortcut, you can use that to double check, but you can't go straight to that. Okay. And now they want the velocity at 2. I just plug in 2. Or if they want the velocity at 1 or 5 or 2.572, anything, just plug in. So I plug in 2. 40 minus 32 times 2, negative 24 feet per second. And that's my answer. So negative must indicate that it's going down. This particle is going down at times. So going up, positive, going down, negative. All right. Okay, so we're doing derivatives now. Okay, limit as h approaches 0, f of x plus h minus f of x all over h. Okay. Okay, 2.729. Okay, it's another messy one. 5x over 1 plus x squared. Find f prime of 2, 29. Use it to find the equation of the tangent line to the curve y equals 5x divided by 1 plus x squared at the point 2, 2. See, what's happening is you got a graph. There's a graph, you know, whatever this graph looks like. We will learn how to graph some of these later on. But whatever this graph looks like, there's a point 2, 2, say 2, 2 somewhere. There's a tangent line. Come up with the equation of that tangent line. Okay. Okay, and we've already seen fractions before. They tend to get very clumsy. So I just make a note, find the derivative at 2, 2, slope of the tangent line. Okay, so f prime of x. Okay, so limit h approaches 0. Okay, so again, use a definition. Go straight to this. Limit h approaches 0, f of x plus h minus f of x all over h. Put it on your formula sheet. Okay, h is always in the bottom. Minus f of x, just copy the original. Normally I'd say put it in parentheses, but in this case you don't really have to. It's, you know, unnecessary here. Okay, f of x plus h. Erase that x, make it x plus h. Erase that x, make it x plus h. Okay, so I get something very messy. Again, dividing by h, you got a fraction on top. Okay, make it multiplying by 1 over h. It just makes things much easier. Okay. All right. So the left side is 5 times x plus h over 1 plus x plus h squared. The right side is 5x over 1 plus x squared. So just like the other fraction one, this side needs this denominator and this side needs this denominator. Okay. So on the left side, I put 1 plus x squared over 1 plus x squared, because that's what I have here. This side is 1 plus x plus h squared. Same thing on top, but in this particular case, it's better to multiply out the top as 1 plus, and now what is x plus h squared? X squared plus 2xh plus h squared. Okay, because I'm gonna have to multiply all of this junk out now. That's a 5. Can't see what I did there. Okay, usually for these kind of problems, don't multiply out the bottom. Leave it as 1 plus x plus h squared, 1 plus x squared. We will have to multiply out the top. Okay, and second recommendation, there's supposed to be a minus here, right? So what am I doing there? I make that a plus and I make that a minus to remind myself that I have to distribute the negative sign. Okay, so I recommend making that a plus, making that a minus to remind yourself it's negative 5x times that, and that, which means they're all going to be negative. Okay, so I have to kind of try to FOIL this out now. To make it a little bit easier, see this 5 times x plus h? Right above scratch paper, I put it as 5x plus 5h. Right, and then I'm going to FOIL that with that 5x plus 5h times 1 plus x squared. Okay, and then it's going to be negative 5x times all of this, which means they're all going to be negative. Okay, so again, 5 times x plus h is 5x plus 5h. So now I'll FOIL here. So 5x times 1, 5x. 5x times x squared, 5x cubed. 5h times 1, 5h. 5h times x squared, 5x squared h. And I'll raise it up again. So these 1, 2, 3, 4, these 4 right over here are from FOILing out 5x plus 5h times 1 plus x squared. And then I distribute negative 5x times these 4. They're all going to be negative, correct? Because that's a negative and these are all positive. So negative 5x times 1 is negative 5x. Negative 5x times x squared is negative 5x cubed. Negative 5x times 2xh is negative 10x squared h. And negative 5x times h squared is negative 5xh squared. Okay, and I'll raise it up again for making it easier to see. Start from the top again and show you. Okay, then I cancel out stuff. 5x cancels, 5x cubed cancels. Okay, then what do I have left over? Let's see, what am I doing here? Yeah, these two right here, 5x squared h minus 10x squared h is a negative 5x squared h. Okay, in green, that one and that one are like terms. So negative 5x squared h. I still got that one and that one. Okay, so I have 5h, that stuff, and that stuff. They all have an h. So factor out the h. So take out the h from here, that's 5, right? Take out the h here, it's minus 5x squared. Take out the h here, it's negative 5xh. All over the denominator, which I'm not multiplying out. 1 plus x plus h squared times 1 plus x squared. Okay, now these two guys cancel out. That's the whole idea. Get a cancellation over here. So these are gone. So limit h approaches 0, 5 minus 5x squared minus 5xh over 1 plus x plus h squared, 1 plus x squared. Finally, I can plug in 0. Okay, so h is 0, put a 0 there, that's gone, put a 0 there. Okay, so that's going to give me 1 plus x squared. Here's another 1 plus x squared. 1 plus x squared squared. So here's my f prime of x, my derivative function. Okay, f prime of x, same as y prime, means derivative. So 5 minus 5x squared divided by 1 plus x squared squared. Okay, I have a rule. I have a rule for the derivative anywhere. So now you give me any particular x value, I can just plug in and I'll find a slope. Okay, so I can plug in 0 or 1 or 50 or pi or e or anything I feel like. Okay, now what did they tell me to plug in? I'm at the point 2, 2. They were giving me. So I plug in 2 for x. Okay, so what about the y? You don't have to worry about the y because the expression doesn't have any y. So 27, let's see, 27. Whoops, did I do that right? I'm at the point 1, 2. Take it back. I'm supposed to plug in 1. So I goofed here. Where was it? Let me double check that. 2.729. No, I have it right. It is a 0.22. 29. And maybe I was looking at 27 temporarily. Yeah, I think I'm good. Anyway, so just plug in 2. So 5 minus 5 times 2 squared is 4. 1 plus 2 squared, squared. Okay, so that's 5 minus 20, right? Negative 15. 1 plus 4, 5. 5 squared is 25. So negative 15 over 25, negative 3/5. Okay, 0.22. Slope, negative 3/5. So y minus y1 equals m times x minus x1. Y minus 2 equals negative 3/5, x minus 2, stop. That's it. Okay. Okay, only a few minutes left. I'll just do one more and then maybe I'll stop. I'm not going to give you anything to do in class today. I wanted to make sure I did as much as possible in order to possibly give you Thursday for questions and answers. So don't worry about doing anything in class today. 2.823. Again, I'm jumping back and forth because the author does that. You give some derivatives in 2.7, some also in 2.8. So 2.823, find a derivative. F of t is 2.5 t squared plus 6t. Okay, again, you may want to do the shortcut. For those of you who know it, you can't, but you can use it, I guess, as a double check. So I'll do that. And what else is involved with the derivative? So I want to make sure I really emphasize the limit definition. I did a lot of these today. Tomorrow I'll do some more of the graphs, the graphical definitions and pictures of the derivative. Okay. Okay, 2.5 t squared plus 6t. All right, so f prime is limit h approaches 0, f of t plus h. So pretend that's t plus h squared, there it is, and change t to t plus h. So this stuff is f of t plus h minus the original function, 2.5 t squared plus 6t, all divided by h. And now it's just some heavy duty algebra. So 2.5 t plus h squared is t squared plus 2th plus h squared. That becomes plus 6t plus 6h. And then minus parentheses means make them both negative. So negative, negative, all divided by h. Okay, if you can't see that already. Okay, that's t plus h squared, 6 times t plus h. Okay, distribute this. So limit h approaches 0, 2.5 t squared plus 2.5 times 2 is 5th plus 2.5 h squared. Copy that, copy that, copy that, copy that, cancel. 2.5 t squared cancels. 6t cancels. So I have that one, and that one. Big surprise. What do they all have in common? H. Factor out the h and cancel with the h in the bottom. Okay. I mean, that's a recurring thing. You might as well pretty much bank that that's going to happen for these problems. You want to cancel that h. So there's going to be a factor of h on the top. So h parentheses 5t plus 2.5h plus 6. Cancel these out. Limit h approaches 0, 5t plus 2.5h plus 6. Okay, again, keep writing limit h approaches 0, limit h approaches 0 until you're ready to plug in. Now I'm ready to plug in, put a 0 there, that's gone. So 5t plus 6 is my derivative function. And so now that means if you wanted a derivative anywhere, at any time, just plug in, very powerful. So what's the slope of the tangent line or the velocity at t equals 0, 1, 5, a million? You can plug it in, okay? And those of you who know the shortcut, double check the derivative is 5t plus 6. That is correct. But again, you can't do that specifically for the test. You have to show me all this stuff. Okay, so we're just about out of time. Next time you'll be seeing graphs like this. So there's some problems in section 2.7 and 2.8 that involve graphs. So I'll start showing you some of that next time. Okay, so just about out of time. Let me see. I don't think there's anything in the chat. Okay, and we're just about out of time anyway. All right, so that'll do it for today, folks. So everybody have a good day, and we'll see you next time. All right, okay, bye everybody. Have a good day. See ya.
Thank you.
Thank you.